Welcome to The Explainer. Today, we're taking a journey far, far below the surface. We are going to descend past the bedrock, way past the public eye, and straight into the heavily guarded, steel-reinforced secrets of global survival infrastructure. Now, when you think of a space program, you usually think of rockets going up, right? But today, we're actually looking at the programs designed to keep humanity secure when the world above ground becomes entirely hostile. We're talking about the architecture of Armageddon itself. It is a fascinating, honestly awe-inspiring look at what human engineering can achieve when tasked with the literal ultimate challenge of survival.
Okay, let's dive into this. What connects the deepest mountains to the silent wars of tomorrow? It's a pretty profound thought, isn't it? We're about to explore spaces that bridge the gap between heavy, physical, earth-moving, and completely invisible digital battlefields. The connection really lies in how we protect our most vital systems from total annihilation. We're moving from the concrete fortresses of the past to the cryptographic fortresses of the future.
And that brings us to the core of our source material, every forbidden space program secret you're not allowed to know. I absolutely love exploring topics like this because these are the literal blueprints of survival that are normally kept strictly out of public view. I mean, they're classified, they're hidden, and they're buried under countless layers of security. But by breaking down this material today, we are going to get an exclusive tour of these covert programs. We'll unpack exactly how these secrets are built to withstand the end of the world as we know it, really diving into the actual mechanics and designs that make them virtually indestructible.
So here is our blueprint for today's explainer. First, the most forbidden places. Second, the engineering of survival. Third, defeating the EMP threat. And finally, the architecture of information warfare. Let's get right into it.
Section 1. The most forbidden places.
First, we need to ground ourselves in the literal, physical, architectural safety nets that were carved right out of the earth. On one side, we have the United States Cheyenne Mountain Complex. This is essentially a self-contained city buried under 2,000 feet of solid granite, sealed behind blast doors that weigh 25 tons apiece. Just massive. On the other side, we have the rumored Soviet Metro 2 tunnels, a vast, secret subterranean network running even deeper beneath Moscow, designed to seamlessly evacuate leadership during a strike. Now, regardless of political ideologies, and neither side is really our focus here, both superpowers faced the exact same existential threat, and they both arrived at the exact same geographic solution. You have to go deep. It's a testament to the shared human endeavor of carving massive subterranean command centers out of solid rock. They realized that the only way to survive the unthinkable was to build a fortress so deep that the Earth itself becomes your primary shield. It's just a crazy scale of Cold War engineering.
Section 2. The engineering of survival.
Now, what's really interesting about this slide is how moving deeper underground completely reframes our perspective on hardcore structural engineering. When we think of nuclear blasts, we typically just feel this abstract sense of dread, right? A fear of total devastation. But for the architects of these forbidden spaces, a nuclear blast is literally just a physics equation to be solved. The engineering of survival means taking the most catastrophic force imaginable and countering it with grounded, calculated mechanics. You can't just build a thicker wall and hope for the best, because a direct nuclear strike will turn even the thickest concrete into dust. You have to design a structure that anticipates the unimaginable stress of an atomic shockwave traveling directly through the Earth's crust.
So this brings us to the actual mechanics. Imagine the terrifying, immense kinetic energy of a nuclear blast wave hitting a mountain. That's step one. The blast doesn't just hit the surface. It sends seismic shock waves violently through the bedrock. If a building is rigidly attached to the inside of that hollowed-out mountain, the sheer force will shatter it instantly. So the engineers implemented step 2, massive shock absorption springs. And we aren't talking about small coils here. We are talking about custom-engineered steel springs weighing 1,000 pounds each. Entire multi-story command centers are built sitting on top of an array of these giants. When the blast wave hits, the springs compress. Instead of fighting the force, the springs just absorb the violent shaking, and that leads right into step 3, kinetic dissipation. The buildings inside the mountain essentially float independently of the surrounding rock. All that catastrophic energy is completely dissipated into the movement of the springs, leaving the people and the incredibly delicate electronic equipment inside totally unharmed. It is exactly like building a massive ship to ride out a seismic wave inside a cave. Unbelievable.
Let's move to and see how this builds into Section 3, defeating the EMP threat. So we've solved the problem of the physical shockwave, right? But there is an invisible threat that follows right on its heels. EMP protection deals with the physics required to shield these deep mountain command centers from invisible electromagnetic pulses. An EMP is this massive burst of electromagnetic energy that follows a nuclear detonation, specifically when gamma rays interact with the upper atmosphere, stripping electrons and sending a massive current spike back down to Earth. Now, it doesn't shake the ground, but it instantly fries unprotected electronics. Surviving the physical blast means absolutely nothing if your computers, your communications, and your life support systems go completely dark immediately after. So the engineers had to design these underground bunkers as massive Faraday cages. By surrounding the whole facility with a continuous conductive mesh or solid steel plating, the incoming electromagnetic energy is routed entirely around the exterior of the room and safely into the ground. It leaves the inside completely unaffected. They literally engineered a solution to ensure that even when the entire world above is thrown back into the dark ages in a fraction of a second, the lights and the data inside the mountain stay on.
Section 4. Architecture of Information Warfare.
So, the crucial point is this: the nature of the threat has fundamentally evolved. The paradigm has completely shifted to the silent architecture of information warfare. For decades, survival meant hiding from a massive, fiery physical explosion. But today, the war isn't just fought with bombs that crack mountains. It's fought silently, invisibly, in the digital realm. A highly targeted cyber attack can shut down a national power grid, contaminate water supplies, or blind early warning radar systems without a single explosive ever being dropped. The infrastructure that keeps a nation alive is no longer just concrete walls and massive steel shock springs. It's the silent architecture of servers, firewalls, and air-gapped data encryption. The battleground has literally moved from the physical world into the very information systems that these subterranean fortresses were originally built to protect.
Let's summarize how humanity's ultimate backup plans have evolved here. We've moved from physical threats, the era of nuclear blasts countered by the brute force of shock springs and deep excavation, to the digital threats of tomorrow. Information warfare requires an entirely different kind of defense, silent architecture. Both eras require monumental, cutting-edge engineering, but the tools are entirely different. We've gone from moving millions of tons of granite with dynamite and heavy machinery to securing billions of lines of code with cybersecurity protocols and network architecture. It is a stunning transformation in how we define a fortress. The modern bunker isn't just a hole in the ground anymore. It's a heavily encrypted server farm operating in total isolation from the public internet.
I want to leave you with a final, rather provocative thought. How does the silent architecture of information warfare surround you today? The deep mountain complexes are entirely out of sight, buried under hundreds of feet of rock, for sure. But the digital battlefield? That's right in your pocket. It's in the servers that run your local bank, the automated grid that powers your home, and the invisible networks that connect us all. These forbidden programs were built to protect a world that has now completely digitized itself. So understanding these secrets isn't just about looking at old, buried bunkers. It's about recognizing the invisible architecture that keeps our modern society standing right now, at this very second. Thank you so much for joining me on this deep dive. Keep questioning what's beneath the surface.